Hi, so here I've got another two ways in which three planes can intersect. They can either intersect by two lines of intersection or three lines of intersection. And what they look like when you do Gaussian elimination of the system of equations is they become inconsistent matrices. So you can see that that's inconsistent because of the lowest bottom third row becomes 0, 0, negative 3. So that's what should happen when it has two lines of intersection or three lines of intersection. But how do we decide, based on our solution, whether or not it's two lines of intersection or three lines of intersection? And then also, how do we find those lines of intersection? So what we need to do is compare each pair of planes. So plane 1, plane 2, and plane 3. What we'll do is compare plane 1 and plane 2, find their line of intersection, plane 1 and plane 3, find their line of intersection, and plane 2 and plane 3 find their line of intersection. Now, knowing that example 3 only has two lines of intersection, we shouldn't get a solution for one of them, so we should be expecting that. So what I've now got is three sets of what kind of looks like simultaneous equations, and it is, but we've got third variable of t, but that's fine because in our line equation we should have that parameter. So what you're then going to do is solve each of those systems of equations for equations in x and y, and then that will give you the system of equations, and then we can compare them. So, to save time, I'm not going to do that because that is just simple simultaneous equation and then rearranging for the parametric form of the equation or the symmetric form of the equation, depending on how you like. But what I'll do is I'll write down the solutions and we will then talk about them. So there, what I've done is jumped ahead and just told the answers, which I'm sure you can work out in your own time. What I want you to notice is, firstly, plane 2 and plane 3 never meet. They do not have an intersection, so that doesn't solve. It ends up with 0 on one side of the equation and a number on the other side of the equation, so it doesn't solve, which means they neither meet nor are parallel. Then if we look at plane 1 and plane 2, we can see that they do meet at the line x equals negative 2t, etc. Plane 1 and plane 3 meet at the line of x equals negative 2t, etc. But if we look at the normals, and you remember the normals to the plane are the coefficients of the parameter. They are the same, which means that the line of intersection of plane 1 and plane 2 and the line of intersection of plane 1 and plane 3 must be parallel. And so that is the only way in which two lines of intersection can happen with three planes, is that two of the planes are parallel. So it is two parallel planes and then a plane going through both of them. Okay? I'm not going to attempt to draw a picture because I'm just not going to. But there's a one in the textbook which is quite good and it sort of really explains it. So what I'll do is I'll show what happens with example 4 when it's 3 lines of intersection. So the first thing would be to get the systems of equations reduced to just the pair, looking at each of the pairs of planes. So there again, I've got 3 sets of simultaneous equations, but where solutions would end up with parameter t in them. Now, knowing that there's 3 lines of intersection, we should get solutions for all of them, but let's see what happens when I jump ahead and just give you the answer, because I'm not going to spend that time doing that, something I'm sure you can do in your own time. So what you can hopefully see is that the normal to each of those lines is the same. It's a half, 3/4, 1, which means that the 3 lines of intersection must be parallel. And again, just like before, I'm not going to try and draw that, but the textbook has a really good picture of that, showing how that works. And again, it's because when you think about how the only way that those 3 planes must intersect must be when the 3 lines are parallel. So it's like a little triangle of the planes. Now, that is the intersection of 3 planes. So the next video will be the last 2, and that's the end of this video.